This video shows how do you use the Excel to plot data, and for this particular lab we plot time versus the positions in Y and X position and also velocity. Well, if you know how to plot one, you know how to plot many. Then let's just plot one of them. So you highlight this, the data to be plotted, this column, for example, X versus Y. This is tennis. So then you go to Insert and go to Scatter Plot. And Scatter Plot, which means basically plot the dots. Okay, here you go. That's the plot. Alright, so you got a plot. Once you have the graph pop up, you can use this to add the titles. You can use this plus to add the titles. So titles, so now titles X and Y. So this is time versus distance versus time as a function. But in this case, it's going straight down, is because my tennis is going to the opposite direction. Okay, in the opposite against the axis direction. But in your data, it may go forward like a straight line like this. So this is going down. This is the velocity versus time, but now it is a function. Position is a function of time. But if you want to get the formula, or in mathematical form, all you have to do is using this cross, plus, and say trend line. And then in this case, you choose trend line, and then expand this, and then you say linear, and then the more options, so you choose this linear. And of course, at the same time, you click this display equation on the chart. So then you see you have the equation part, and there's a straight line. So basically, you have this line have straight line equation. But in this case, you should understand this is the X, and that's a T. And of course, this is just a generic math expression, realizing that this X is negative 1.6. That in front of the independent variable, that's our slope, that's a velocity. See, the velocity is negative 1.6 meters per second, and that is the interception, which means where actually it started and the object from as the coordinate system. So now to plot multiple columns, and you need to be careful, play the trick. For example, in this time you plot X, time, and Y. So Y versus time. Then what you do is to hold the control, select this X, but instead of X, you hold the control key. Once again, hold the control key to select this, and then the rest will be the same. So the Y direction is kind of interesting plot. It's a scatter plot, and you see, then you see this will pop up. And then the horizontal direction is X, the vertical direction is Y. Again, you can choose to add titles, and on a vertical direction, it is Y, and it's in meters. And in the horizontal direction, it is obviously X in, time in seconds. So that's how you plot. Once again, you have to hold the control key, choose time, and hold control key. Okay, otherwise you select everything. I hold that, and then do the rest. If you want to plot Y direction, you need to choose Y column and time, these two. But see, there is a X in between. But to hold to select these two columns, okay, to skip X, then you need to hold the control key and select this one and that one, and hold the control key X, and then hold this one and choose this. So Y versus time, and then do insert scattered plot. Then you will have this. So you have Y versus X. Now you cut this into, again, you can change the title from here, change the units, and so on. And also, but now you see this curve, why it look like this? Why it's not in the middle? See, in the case that in my case, the tennis ball is leave the hands at 0.8 seconds. In other words, from 0, that's the starting point of the video, instead of where the tennis is released. So if you want to plot this, you need to give a shift. Okay. So before we do a shift, let me show how do you fit with the curve. In this case, it is a quadratic formula. It's an accelerated motion in right direction and reduce the speed and then increase speed. So you go over here and you choose trend line again, but trend line again. So here, trend line. Now again, here one more time, trend line, and then more options, more options, more options. Choose quadratic fit. So you'll be up here, and polynomial. It's an order 2, which means squares. At the same time, click display equation. So you see the equation is here. And this is the generic equation in mathematics. In our particular case, the y is actually our y here, but the x is our t. So we have a quadratic function describe this y versus t is this. All right. So now we try to, but this equation is really not usable because this equation will fit exactly. See the quadratic curve fit, but we want to do a shift the 0 to wherever the tennis ball actually starts. Instead of starting 0.8, we want to start from 0. To do that, we have to create a new column of data. Once again, to shift this curve, we have to prepare a new data, which means we have to prepare a new column of time. Well, to shift the time, we go on axis. We need to prepare a new column of data. So over here on the Excel, insert a column. Over here, right click, insert. So you see I have a new column. Over here, I would say time. In this case, my tennis ball actually released hand at the offset. So I would say offset. Okay, offset, and we'll make offset 0.8 seconds because I want to make that to be 0. Offset 0.8, so offset seconds. So this column, therefore I will subtract from here 8.8 seconds. So then wanted to do that. So this is like function on Excel. So this is a very useful universal. So equal, and then you will say A2, that's A2, okay, and minus 0.8, which means this cell minus 0.8 will be here. So if you press enter, it's 0 because that's simply that minus 0.82. Now you want to apply to every of this, then you prepare the whole column. You don't have to time everything minus by. What do you do? So this minus 0.8, what do you do? That's the beauty of Excel. You should hold this little square, not in the middle, and pull this all the way, which means you want to apply the same trick to every data point. So see, it fill up everything. So which means this cell minus 0.8, you get this. That one minus 0.8, you get a 0.2. So you sort of examine them, a couple of them, so just make sure it did the right click. So I have a new column data, which is, so this time is really using the starting point of the tennis ball traveling. That's where the tennis ball leave your hands as 0. So now you plot the new plot. Instead of that, see this one start from 0.8. Now you from here start from 0. Basically, you redefine your time. So now once again, you select this one, hold your control button, and select Y. So basically, you want to plot Y versus the offset time. So you plot this, and we'll start 0, and then once again, you insert the scatter plot, and done. It's the same curve, of course, but it's important to notice it starts from 0. So that's 0 is, okay, so then of course you can change the title. So that time, this time, you say time, of course, t, and of course to make a note, okay, and offset 0.8. So that's just, you know, to compare with the other plot. So offset 0.8, and then of course that one is again your data in y. So y position in meters, and so the title of the plot is, instead of y of m, is actually y of t. So this is the function of vertical distance versus t. So remember, this is not y direction anymore. The horizontal direction now is a time. Time, not meters. Time in seconds. So time in seconds. So that is your y direction. And then if you fit that, recall your mathematics, quadratic equation, you can have a shift to the right, shift to the left. So this is, you have to use the equation of the shifted equation. Now you do the same thing as we see in the previous, from the previous term. You do the trend line, and here choose more options, and then find out. All right, trend line, more options. All right, so let me put more options. You click here actually. Click here on this, and you do quadratic polynomials and choose 2, that means quadratic, 3 means cubic, and you fit the curve, and then you display the equations. So then you will see you fit the quadratic line over here. Alright, I don't want the linear one, so you delete the linear one. So that's the equation. Now see the equation changed. So the one that's without an offset, the second term with 17, the second term with 5.9, and that one initial point, it was 0.95, 9.5. That one is 0 by 0. Remember, you have to use the 0. You have to use a shifted one. Otherwise, the parabola is perfect, but the time is shifted. So it doesn't make much sense, because you can have a lot of time may have passed since you released the ball. So you have to shift to exactly what time the ball released. So this is the case. Then you copy this, and then you can move on for your lab.